Yes, good afternoon to all. Jadhav madam, acknowledge, please. Are you listening? Are you be able to listen? That is what I am asking. One or two, yes or no, once you tell, so that I can go with. Good afternoon to all of you once again. Director, Major General Samir Kalla, Technical Director M. Pulambarkar sir, Patron Dr. Suhas Khot sir, Principal of the College of Engineering and Management Research. In short, we say KJCOE MR. Convener Dr. Prajakta Deshmukh, FE Coordinator, Head of the Department, Professor Asha D. Jadhav. Organizing committee has many members over there. According to leaflet, advice teaching faculty and participant. Once again, I got opportunity after 2 years, and I really appreciate in the beginning only. Deshmukh madam, Sane sir, and mathematics faculty of the college, they are really taking efforts to conduct continuously the workshops. This STTP, 1 week IST sponsored STTP on applied mathematics in science and engineering. It is 6th of July. Initially, I was busy with one of the workshop. I was attending FDP at my college. So today only I got some relief from the previous workshop. The topic is very simple. Laplace transform. Many of us are quite familiar with that. But here, if we go with the applications, for that some revision part I may require to go with, and then we'll go for a special functions, their application, and corresponding properties related to engineering, where we may require. Actually, it is an integral transform techniques, we call it. We used to have all transforms in integral form, and there we are going to learn. Many of us has learned basic thing. You see that the difficulty I will discuss in general first. That uh, earlier that this subject topic was there in our all curriculum to all branches initially from 90 to 2000 or 2002 up to that. Thereafter, I don't know, something had happened, contents or why is that other branch specific, they find it easy for teaching, and then they uh, criticized us that you are calculating and our question paper based on their questions in the paper, they were for very difficult functions, the transformation we were asking. And then they took, and from there they started teaching. But according to me, yes, everything, if one has to be an expertise in teaching, he should know many a times we confuse, can we have a Laplace transform for this function? And application part is rather later part, but initial transform, it may be an just repeating thing, but in brief I will have to go. And then I will go with, actually these transforms are defined in many of the literature in both way. That is, if you take it a forward Laplace transform, inverse Laplace transform also has to be taught simultaneously. But considering in the colleges while teaching, we go with the two parts separately. First is just we define Laplace transform, we go with all elementary transformation, then we go with all properties those are important. It will be useful while solving certain problems if you apply the property rather than basic thing if we are applying. And then only basic definition is applicable to all the functions. But here it will be difficult to apply those functions, get evaluated integrals and other things. That will lead to a complicated calculations. But you know that properties, sometimes change of scale and depending on that we may move. Change of scale says certainly in f of t domain certain thing is known to you, then it's a corresponding on its transform. So one introductory remark I will make it on Laplace transform, then Laplace transform theorems and properties, Laplace transform of special function, inverse Laplace transform, then it's the properties or theorems we can call it, then application of Laplace transform to solve linear differential equation. One also we required an all explanation from very big thing of complicated questions or other thing, but certainly one or two three examples will take it on linear differential equation of different types, and then we'll try to solve how it will be applicable to partial differential equation also, which was not there in our content. But I find it very simple for application to partial differential equation like Fourier transform for mechanical branch. Many of us are taking. I don't know how the students are convinced with these transformation and their techniques. In that case, then some other applications are also there. There we'll just discuss those things, how we can apply it to engineering application, that is civil engineering application. Then electrical engineering, we'll see that if it is not resolved, and then a biggest part comes as an for chemical engineering. Chemical engineering, the control systems and other things, industrial applications are there. I was there in Bharati Vidyapit. I had we had a chemical engineering department, and I find out there were some professors. They were discussing transport phenomena and other topics of chemical engineering, and I had discussed it at length to them, and I could get some knowledge over there that there we go with at the beginning of some process, what it is there, how it will be going, those and then solution of nth order differential equation they required single tank, two tank, with or without interactions, and many applications are there at we may understood those things, and that we may contents I can discuss. Though I had made it very simple so that just show that those of you are totally new to this field, that is 1 or 2 years are there, then 3 years or even up to 5 years, they may find it more useful. Others, like I don't know, Damle madam is there. If she is there, I don't want to teach her anything because she is quite senior. And similar, if Anurag sir is there, they are teaching this part since long time. But then why I had chosen, I could have gone for many other topics also. But those topics, last time I had covered that mathematical modeling of a mass spring system with force, without force, with dam, without undam, and these things. And then And so the case with this Laplace transform also. If anybody has any question, can ask with the voice, because I'm not able to find out my screen, any other part of the presentation, or presentation screen, except my PPT. I don't know how it can be made it long after long time. During pandemic, yes, I was there, and I find these type of presentation. Otherwise, pen drive or personal presentation, I more prefer. And really, I can say that due to heavy rain and many other things, uh, excuses. I had a call also from Khot sir. Convey my thanks to him, mathematics community, whenever they are there for some STTP like thing. And IST is giving us, then college is taking a lot of efforts. Really, thanks to them. Deshmukh madam is ever, though she belongs to physics, I think, but still she is taking a lot of introductory remark. I would like to say that for all engineering teachers, we had a discussion about with our coordinator Radhika Madam for an workshop. Yes, workshop will have to conduct before start of our college. So proposed date is 10 of 10th of August comes out. Yes, we'll certainly go with those workshops also. Not much of a change in there, but units are 5 units and other thing. We'll have to make it everybody proposed plan for evaluation and assessment. That will be an important. But let us wait for that. Actual schedule comes from Government of Maharashtra CT cell, and after that, how the process of first round, second round. In between that, we'll take it one workshop also. So need not to ask anything. We are there on the track. We are talking with the host colleges that who can help us to conduct these type of our workshop, 1 day workshop, and then we'll go with this. Now I begin with my first slide, introductory remarks on for this. So everybody knows that Perry's Simpson Laplace is a French mathematician. He is a French mathematician and statistic, the great scientist who has given us Laplace transformation. So we go with Laplace transform is the most important and powerful tool for making transformation is a technique directly or otherwise, make it the it is widely used for solving differential equation. The Putta method is also used. The similarly Laplace transform techniques are also used. Only the thing its compulsion comes, mechanical or electrical driving forces, when they are of different nature, unities they are, or large force acting for short duration, some by name, and here we call it is direct delta function or unit step function. So those functions are there. Then one more type, periodic functions may also be there. For a differential equation, driving force are of this nature. Then in that case, we have to case, even it is impossible to solve by a basic method. We need to go for transform technique, and then we can solve the problems. I can say that basically, we in this presentation we start with the basic definition which everybody knows, or maybe brief only will go, and we'll try to understand the actual understanding of this Laplace transform. Later on, special function, unit step function, direct delta function, also called Heaviside unit step function, periodic function, and many function, and it is are also discussed. That is what is it mean? Error. Many things are there in a mathematics, which I may be also having less knowledge than what I am speaking. That it can be applicable to many of the situation. As and when we will proceed, we'll see that. I think that basic definition. So Laplace transform, then it's the definition first we'll understand, and then we'll go with the properties. So the for any function to be Laplace transform, then to find, can I talk about that transform? What for we require transformation? In element of origin is a transformation. Matrices also we go with some transformation. Then taking logarithm, very elementary level, a into b, if we take logarithm. So multiplication is somewhat difficult than addition. Log table we make it in our research also. For what purpose? To reduce the units over there, and then we take the x-axis. Your calculation becomes more simple, or t defined for all t greater than 0. No, one-sided and two-sided, both sided functions may be there. We are discussing at this moment only one-sided. Two-sided sequence with causalness, and we can go with other things also. But it's to begin with, we start with Laplace transform, which is defined for any function which is for on right side of origin. Then the Laplace transform is denoted by this integral sign. If you find it's a definite integral, one kernel is there, e raised to power minus st. It controls the constant values. We know that if it is a definite integral, yes, the result has to be f of s. So left hand side, what we are finding, there is a function f of t in t domain, time domain, mostly more helpful to even mechanical also. Time related thing, any signals or related forces are there. Then in that case, f of t is there. Then we shift it by this. What is this integral? Integral is we are shifting to some other domain where s may be a parameter, or rather we are saying that it may be real or complex. So both the things are possible. Once we go in S domain, that is generally we call it as frequency transformation, finite Fourier transformation, and other things are there. All those analyses are transform nature. So once this integral exists, we say that Laplace transform exists for the given function. But then we'll go with the condition for that function to have a Laplace transform is to be discussed for its convergence. And what is that? That s term, s parameter is going to control the integration, and whenever we will be to have some will exist. For example, here only we can say that if s is negative, then what will happen to upper limit? And so it may create a problem for me to get an integral result, because it will become positive exponential term, and with time t goes to infinity, it will exponentially increasing, and hence we will never get in convergence. So that kernel will control the integration, and we will find we'll be more concentrating on what s, though in our teaching it is okay. At a higher level, whenever we are using it for any research work, we'll have to concentrate totally on s, because what we are going to do, it converges, that is, we get in Laplace transform, and then only we are discussing. So all those s which will which will is it possible to have for every s, for every function we this integral will exist? We cannot say, and for that purpose, two things we required to discuss on for Laplace transform to exist for the function. And the second I will go with the piecewise continuous function is the necessity, and function of exponential order. So what do we mean by piecewise continuity? With the figure itself is self-explanatory. From both the sides, the function should have limit to exist, and then we can have. So wherever breaking intervals are there between A to B, then in that case, even if sub-intervals, it is defined many sub-intervals, but it should not have infinite discontinuity. That is what only important part is there in this particular place, either of the side. If we approach to particular T2 or T3, we'll find that some limits are there. So every sub-interval it has to be continuous. That is what the one thing for Laplace transform to exist for given function f of t. And then function of exponential order. Now this definition, sometimes we understand properly, sometimes we don't understand. But if there is a constant alpha, now in terms of alpha we are saying, with the property the alpha t must be continuous. That is what alpha t basic definition we are talking of. For some alpha, if this remains bounded means finite, then f of t is said to be function of exponential order alpha. As t tends to infinity, how do we understand we can pronounce alpha what it is, but there must be some it should exist, or it should be function of exponential order alpha. What does it mean in mathematical terms? In other words, there are constant m and n. Now two constants I am introducing in this. Alpha is an constant of exponential order alpha. If I take it, it should less than m. M is some constant. Mean there must be some reference from where you can start with, and then up to whenever you go for t goes to infinity also, but from some reference point. Any curve also we draw, there is a reference point is the reference for anything. Greater than that we will be experimenting for that t will make it to infinity, and our left hand side e raised to power minus t modulus f of t should remain constant, bounded, that is less than some number m we are saying. So what is meant by bounded? Then if you are going, then still it has to be m is less than n also you make it, but there should be all t's for all t goes to infinity, it should satisfy this condition. And another word, if we say that if a function is of exponential order alpha, its absolute value must not increase more rapidly. What does it mean? What does it mean? Then now we take it e raised to power alpha t, mathematics is there. We can see that modulus f of t should not be going more faster convergent or increasing, then f of t should be less than m into e raised to power alpha t. A simple example we had taken, t is behind it. For all t, this will be true that what relation we had made it, t square is less than e raised to power 3t. Whereas it will fail to another example number 2 is not a function of exponential order. You put it in the form of exponential order.